I now would like to talk you through an example of how to add vectors, and then after that we'll do how to subtract vectors. So when you're adding vectors, you need to identify initially 2 vectors that you're adding. You can, of course, add multiple vectors, more than 2 together, but you'll want to initially add 2 together, take the result of that, add it to the third, and so on. So we're going to start just with 2 vectors. I have vector A and vector B. Note that both vectors are coming from the same position. What defines vector A is its length and direction. What defines vector V is its length and direction. So in this case, they're happening to come from the same position. That doesn't actually matter. So when we add them together, I want to take vector B and actually move it so that the tail of vector B is at the tip of vector A. So these 2 vectors are the same because they have the same length and the same direction. It's okay that they're actually located in a different part of space. Then to add them together, all you need to do is draw a line from where vector A starts to where vector B ends. This is then going to be the sum of these 2 vectors, which I can call vector C in this case. So it's important that you actually go through this systematically and add vectors this way, because we're going to use the same approach with one important change for doing subtraction. I know that there are some other techniques that you've possibly learned of doing vector addition. Now, one thing to be careful about is that students sometimes misremember how they've learned to do vector addition in the past, and they've done it the wrong way. Perhaps the worst thing that you can do when you're adding vectors is look at these 2 vectors and draw the resultant vector from the tip of vector B to the tip of vector A. That is absolutely wrong. Don't do that. For any other technique that you know, for it to be a correct technique, it will actually end up being effectively the same as this. So please be careful when you're adding vectors. Make sure you're using this stepwise approach. The second thing is subtracting vectors, which is going to use the same stepwise approach, but I want to remind you of 2 basic math ideas first. The first is that if I want to subtract one number from the first number, I can think of that as adding a negative number. So this isn't anything special about vectors. This is just how math works. So 2 minus 4 is the same as 2 plus minus 4. We're going to use that idea when we subtract vectors. The second thing to remember is that 2 minus 4 is not the same thing as 4 minus 2. So the order of subtracting vectors is very important. Addition doesn't have this problem. Addition, the order doesn't matter. But in subtraction, it's very important to get the order right. So let's, in this case, subtract vector B from vector A. And again, it's important to note that B is the one that is going after the subtraction symbol, and so we need to make sure that we preserve that order. So the first thing we're going to do is we're actually going to look and use this sort of a rule. We're going to create what the negative B vector is. The negative B vector has the same length, but is in the opposite direction. So if I started at the same point, it goes in the opposite direction by the same amount. So this new vector here in the dotted line, that's my negative B vector. Now, all I have to do is add my negative B vector to A, and that will give me the result. So remember from addition that we move our vector so that the tail of the second vector is at the tip of the first one, and then we add them by drawing a line from where, in this case, A starts to where B ends. And I'm calling this vector D. Vector D in this case is representing B subtracted from A, or you can think of this as A plus negative B. So again, I've used the same approach for addition and subtraction, but in the case of subtraction, I've created the negative B vector and then added it. So please be careful that, again, you're not just drawing from tip to tip or taking any shortcuts. If you think you're taking a shortcut, you're probably doing it wrong. So I'd now like to give you a chance to kind of practice this by thinking about a fairly complicated scenario. In this case, there are actually 4 vectors. A's here, B's here, C comes down, and then D actually comes back to the original position. Now, there's 4 options here, and one of them might be a mathematically accurate statement that represents what's happening with these 4 vectors, or maybe none of them are. So I won't read these aloud, but I'll let you read through them. Please pause the video, think through whether any of these 4 statements are correct, and if so, why. So the best answer here is actually B, that the sum of A plus B is equal to the negative vector of the sum of C plus D. Now there's a few ways to think about this. The one that I'll show you is that if you look at A plus B, it's actually already arranged in the correct way. That if we just draw a vector here, which I'm not very good at drawing straight lines, we see that this is in fact A plus B. It would be ideally a straight line that goes from our starting point of A to the ending point of B, which takes us up there. Now, if we then look at C plus D, we would be starting up here and then coming back down in ideally a straight line. And you note that these two vectors have the same length, but actually opposite directions. And what that means is that if C plus D is going from up there to down here, negative C plus D would start at the opposite position and go backwards, which gives us back A plus B. So B is the best statement here. We didn't actually need to do any vector subtraction whatsoever, and the vectors were actually already arranged in a way that made it easy to see this. So all of the other statements are not actually true here, and you would have had to do some additional vector addition to really check that A and C were not true, and D in this case are not true since these two vectors are in opposite directions. So B is in fact true. So to summarize, the most important thing to know is that vectors always have a magnitude, which is their size, and a direction. We can think about this as the vectors start in a place and go to another place, but the distances between those and the direction is what we care about, not the individual position that the vector is at. Now, the big difference between a position vector and a displacement vector is that the position vector starts at an origin and goes to one position, where the displacement vector is the difference between two different position vectors. When we talk about one-dimensional vectors, we can use the sign, either positive or negative, to imply whether the motion is in the left or the right direction, if it's usually the x-coordinate, or in the up or the down coordinate for the y direction. So finally, if you want to add vectors, please make sure that you're using the tail-to-tip method, and you can subtract vectors by first taking the negative of your second vector and then adding it to the first.